a cone has a circular base and a vertex that is not in the same plane as the base. What's up? I had to hide them. Okay. So we kind of already know this, but in a right cone, oh, I skipped over reading this. Okay. The radius of the base is the radius of the cone. Okay, the height is the perpendicular distance between the vertex and the base. We already know all that. In a right cone, the segment joining the vertex and the center of the base is perpendicular to the base, and the slant height is the distance between the vertex and a point on the base edge. Okay, that was a lot. Okay, so what you need to know is that in a right cone, the vertex is like perfectly over our center of our base, right? Okay. So inside of that cone is a right triangle. Did everybody see that? Okay. So part of the right triangle is the radius of our base. And then a really important part of the triangle is this, which we are going to call our slant height. We're going to call it L. Lowercase, cursive E, kind of L. Okay? Okay, the lateral area is it lateral area or lateral surface? Guys, we got to go back and check. Lateral surface. All right, sorry about that. Of a cone consists of all of the segments that connect the vertex with the points on the edge of the base. So if you can imagine infinitely many segments, like packed in tight as sardines, you see what's happening? Like if I put infinitely many in there, I'd like cover the whole cone, right? Okay. Look up my drawing. Okay. Surface area. When you cut along the slant height and base edge and lay a right cone flat, you get the net shown at the right. Okay, so that's what you've cut out minus the base, right? So I just remember that kids used to be really confused between the height and the slant height of the cone. So when you put this thing together, this edge, that's your slant height. Does everybody see that? So I want you in big letters, as much as possible, to label that with the cursive lowercase l. Like this. That's your slant height. Do you see that that is the radius of a really big circle? Okay. Do you remember in our last unit when we found sectors of circles? When we found the area of part of a circle by finding like what part of the circle that was by putting that angle measure over 360? That was to step us up for this formula today. Okay. Okay. Okay, when we cut along the slant height and base edge and lay a right cone flat, you get the net shown at the right. The circular base, has an area of pi r squared, and the lateral surface is the sector of a circle. You can use a proportion to find the area of the sector as shown below. So your area of a circle area of a sector compared to the total area of a circle is going to be equal to the arc length compared to the total circumference of the circle. Okay, so what that's saying is if I have like this 1/4 of a circle, can everyone see that that's 1/4 of a circle? This area is 1 out of 4 pieces of the total area. So its arc length should be 1 out of 4 compared to the total circumference. That's all it's saying. Everybody happy with that? Okay. So as long as you do part of area over total area, part of circumference over total circumference, you should be good. Got it? Mm-hmm. Okay. So then we're just rearranging. All right. When I look at these two, I see that we multiplied, both sides by this denominator. Do you guys see how that denominator went away? So I multiplied this side by pi L squared and this side by pi L squared. And why am I using that crazy L? Yeah, it's the slant height, which is the radius of this big circle. Everybody okay with that? Okay. Okay, why are we using an R for this piece? Because the base of your cone is a circle, so you have to do the base. Yeah. So the base of our cone is this little circle, right? And this circumference right here is 2 pi r. Everybody happy with that? Okay, that has to be also this arc length. That one also has to be 2 pi r. Everybody okay with that? Okay. I'm going to write that here. Oh, it says it on the diagram. All right. I was like waiting for that to be an aha moment, but it's already on the darn picture. Okay. So once I multiply both sides by pi slant height squared, these cancel, and I'm left with my area of a sector equals pi slant height squared times this little guy. And then I can just cancel some stuff. Okay, my 2's cancel, my pi's cancel. I have an r left over, and I get to cancel one of my l's. So if I have l squared over l, you see that I just have one l left? Okay, perfect. Okay, so the surface area of a cone is the sum of the base area, pi r squared, and the lateral area, which we just found, which is pi times the radius of the base times the slant height. Notice that the quantity pi r slant height can be rewritten as this, which is kind of crazy looking. Okay, let's keep moving. Okay, so if we want the total surface area, we have to take the lateral area and the base area and add them together. Boom. Any questions about that? Okay. Let's do some examples. Hey, would you shut that door? I'm going to need all the help I can get anyway. Okay, so our surface area is our base plus our lateral area, where our base is pi r squared, and our lateral area is pi times our little radius times, do you remember? Isn't it the slant height, L? Did I get that right? Tell me now if I messed it up. No, that's right. Okay, thank you. Okay, so all we have to do is figure out what our R and our L are. Our R and L are. So, do we know what R is? 6. Okay, well, there's one down. R is 6. So, on our picture, L is right there. Everybody see that? Yeah. But we have here a cute little right triangle. Yeah, we can use Pythag. Does anyone see anything else? It's a 6, it's an 8. Oh, you can use the triples. Yeah, it's a Pythagorean triple. So yes, you can use Pythagorean theorem, or you can see that it's a 3, 4, 5 right triangle. 3, 4, 5, it's just multiplied by 2, right? Times 2, times 2, times 2. So what's 2 times 5? 10. 10. So our L, L is 10. Okay, let's just plug that in. So we've got pi times 6 squared plus pi times 6 times 10. And it says we want an exact answer with pi left in the answer. So we'll just simplify our coefficients and then combine our like terms. So 6 squared gives me 36 pi plus 60 pi. I'm getting 96 pi. So our surface area is 96 pi meters squared. Okay, so there's a lot going on now. I can ask you for a height, which would be in linear units. I could ask you for an area of a base, or a lateral surface area, or a total surface area, which would be in square units. Or I could be asking you for a volume, so just make sure you're watching your units and their power. Any questions about this? Okay. Do you guys want to try? Oops. Sorry, guys. Thought I recorded that. Was it recording the entire time I was gone? Awesome. Yes. Uh-oh. Okay, we don't know. Okay. It is what it is. Okay, well, it's a prism if it's got a base on top and a base on the bottom. It's a pyramid. Okay. See the pyramids along. Da, 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 da. Okay, in which the base is a polygon and the lateral faces are triangles with a common vertex called the vertex of the pyramid. The intersection of the two lateral faces is the lateral edge. Okay, any two lateral faces is a lateral edge, I should say. The intersection of the base and the lateral face is a base edge. Do you guys see the difference between the lateral edges and the base edges? Okay, perfect. The height of the pyramid is the perpendicular distance from the base to the vertex. Okay, we knew that. Okay, a regular pyramid is going to be one that has a regular shaped polygon as a base. Okay, so all the sides are congruent, all the interior angles are congruent. Okay, perfect. Okay, I don't know what this blank is. We're going to go figure out what this blank is. Oh, regular pyramid. Didn't we just do that? That's fine.
A regular?
Yeah, a regular pyramid. Has a regular polygon for a base, and the segment joining the vertex and the center of the base is perpendicular to the base. The lateral faces of a regular pyramid are congruent isosceles triangles.
Lateral?
Yep, slant height. Good. Okay, so you can see this triangular face right here, right? So if you look at just that face, the height of that triangular face is this, which is our L, slant height. Good job. Okay. A non-regular pyramid does not have a slant height. Good to know. Okay, a regular square pyramid has a height of 15 centimeters and a base edge length of 16 centimeters. Find the area of each lateral face of the pyramid. Okay, well, they're all going to be the same, right? Because I've got a regular square pyramid. So let's just find the area of this face right here. Pick your favorite. Is this part of the same problem? Oh my gosh. Okay. So I'm just going to redraw this face so that I can mess with it. Okay, so this is my triangular face. This height is my L. Okay. I know that my base is 16. So what would this piece right here be?
8.
8. What else do we know? Oh, yeah. Okay. There is another right triangle inside the pyramid. You guys see that one? It's this guy. Everybody see that one? Okay, we're going to draw that one here. Okay, so on that one, the L is going to be the hypotenuse. Does everybody see that? And we know that this is 15. Okay, so we still know that this base length is 16. Isn't this 16? And this is 16. And this is 16. You guys see that it's 16 all the way across? Okay, so if it's 16 all the way across, what is this piece right here? 8. So can we find our slant height?
It's 17.
What?
17.
It's 17. Okay, how did you get that? Did you remember it was a triple, or did you have to use the Pythagorean theorem?
I saw it on the test.
Okay. It's a triple, but that's one that I can never remember, so we're just going to Pythagorean theorem it. Okay, so if I do 8 squared plus 15 squared, I should get my slant height squared. Okay, so 8 squared is 64. 15 squared is 225. So 64 plus 225 is what? I'm getting 289. Okay, and then when you take the square root of that, you get that the slant height is 17. Okay, now we can use that information over here. So now we know that this L is 17. So the area of our triangular face, I'm going to call this the lateral face area. That's 1/2 times the base. Well, it's not just the 8, it's the 16, right? Times the height, which is our 17. So what's 8 times 17? What did you just give me?
Quiz.
Okay, thank you. I'm getting 136. And that would be centimeters squared. All right, that's not so bad. The hardest part, I guess, would be to see the different right triangles in the picture. Okay, so just remember our tools. Remember how we used to draw like the separate pictures? Okay, that's going to be your best bet. So you just, like my instinct was to draw this triangle first, but I did not have enough information to find anything else out about this picture. Did you guys see that? So then I had to find another triangle in the picture, and that's when we went to this blue one. So you just have to start working on the piece, like the triangle that you have the most information for, because that's where you can start solving for your unknown parts. Does that make sense to everybody?
Yeah.
Okay, good. All right. Cool. Let's do this one. All right, we're looking for the area of a lateral face. And we know that this is a regular pentagonal pyramid. Okay. Saved by the Bell. We're basically going to be doing the same thing. So I want you to find the little triangle that's sitting inside this regular pentagonal pyramid. Okay? I'm going to redraw that little triangle here. Whoops. Okay. Here's my right angle. The height of this pyramid is also the height of my triangle, this 4.8. You can see the apothem of the base. See, everybody see the base? Okay, the apothem goes from the center to the center of the side. That's 5.5. And what I don't know is my slant height. All right, this looks ready for the Pythagorean theorem to me. 4.8 squared plus 5.5 squared equals my L squared. I don't know what that is, so I'm going to use the calculator. Okay, I'm getting 53.29. If you guys already have a number like this pulled up on your calculator, do you remember that square root is the 1/2 power? Remember that from Algebra 1? So instead of doing like square root and then having to retype this, you can just do power caret 0.5 and it'll take the square root for you. Try it.
What is it? Power carrot 0.5?
So let's say, all right, I'll show you on my calculator. So it's 4.8 squared, right? Whoops, hold on. Girl. Okay, plus, was it 5.5 squared? Okay. Now, could I now type in like second square root, yada, yada, yada?
Yes.
Yes, but that's a whole bunch of extra keystrokes. Plus, my calculator has already saved this as an answer, right? It's in the calculator's memory. So if I just do power caret, it's taking this stored answer and raising it to whatever power I say. And if you remember that the square root is the 1/2 power, you could do 0.5, boom, you just took the square root in 2 keystrokes. Nailed it. That's some next level right there. You like that?
Yeah.
Yeah. Good. Thank you. So the slant height is 7.3. If I would have showed you that when you were a freshman, though, you probably would have never come back. Okay, so we have our slant height. Now we're going to look at this other triangle. Everybody see this face. Okay, that's this triangle. Pew, pew, pew. So the slant height is the actual height of this triangle. Right? And we know what this is. It's 8. And we know that our L is 7.3. So we just have to say that the area, the lateral face area is 1/2 times the base times the height, which is the 7.3. So what's 4 times 7.3? I got 29.2. That's meters squared. So the strategy again was to start where we only had one piece of missing information that we could solve for, right? And then once I move that over here, I can use that piece of information that I found to find more missing information. Sound good? Okay. Is that the end of that page?
Yes.
Okay, now that we know how to find the lateral face area, do you see how this is going to turn into a formula of sorts for a pyramid, surface area of a pyramid? We know how to find the area of each of these cute little lateral faces, right? Right? So if I wanted to find the whole lateral surface area, I just have to multiply the area of that one face times how many there are. So here there's 1, 2, 3, 4, 5, 6. So I find that area, multiply it by 6. Now I've got the lateral surface area. Good? If I want the total surface area, I just find the area of the base. Boom. We've been doing that for 2 units. And add it to the lateral area. Cool? All right, here we go. So I'm going to find the surface area. That's the whole kit and caboodle. And it says that this is a square pyramid. You want to start with the small potatoes, the easy, the low-hanging fruit? Start with the base. So if this is a square pyramid, that means the base is a square, right? So it's 48 by 48 for the base. I'm getting 2304 inches squared. Okay, that was the warm-up round. Okay, now we're going to use our tricks to find the lateral area. So our total surface area is our base plus the lateral area. Okay, so we have to use our tricks to find the area of one of the faces. And how many faces are there?
2, 3, 4.
4.
Oh,
Okay, so
yeah.
we'll just find one triangle face, right, and multiply it by 4. Sound good?
Yeah.
Okay. So, they didn't make it for us, but you know from the last couple that we can find this cute little triangle inside the pyramid, right? Okay, start by drawing him. And we know that this entire distance across is 48, so if I just take half of that, what is it? Don't all say it at once.
Purple.
Did you say purple? Okay, well that's not right, but thank you for playing. It's 24. Everybody see that half of 48 is 24?
Are you seriously singing the words right now?
Okay. Focus. We're almost done. Okay. So, do you see any fun common factors in the 24 and the 32?
They're even.
They're even, bigger than dividing by 2. Anything else divide out? Nope, not 10. Smaller than 10. Bigger.
6.
Nope,
3.
nope.
8.
8. Do you see that they're both divisible by 8?
Yes, because 48.
Okay, so this pink triangle is the one I'm talking about right now. Okay, so what is 24 divided by 8? All right, stay with me. 24 divided by 8 is?
3.
3. 32 divided by 8 is?
4.
4, which makes this a 3, 4,
5.
5 right triangle. Okay, everybody sees it?
Yep.
Okay, so if I'm multiplying my 3, 4, 5 right triangle by 8, what is my L, my slant height?
40.
What? 40. Because it's 5 times 8. Good. So my L is 40. Good. Is that all we needed? Yeah, because we already know the base of that triangle. Cool. Here we go. So my LA, we already said that there were going to be 4 triangles. Each of those triangles is 1/2 times the base of 48 with a height of, here, this is the one we're doing right now, this base. It's got a base of 48 and a height of my L, which is 40. Right? That's this one. Okay, I'm losing you. Focus. 48 times my 40. Okay, so 48 times 40 times 2. I'm getting 3840.
Yep, me too.
This is my lateral area. Sorry, I forgot the L in front of it. Lateral area is 3840 inches squared. So if I add those two together, my base and my lateral area, I'll get my surface area. I'm getting 6144.
Yep.
Okay, do we need to do this last one or are we good? Okay.
I'm celebrating birthday today.
All right,
I think
we're recording. We're live.
probably the right.
Hey. It's okay. Okay. So inside of our hexagonal pyramid, we have our fun little right triangle. Oh, yeah, no, we're not going to do this one. Just kidding.